In this video, we'll be looking at how the mole is related to Avogadro's number. Atoms are really small, and they're so small it's not practical to try and weigh them out individually. So just as we say a group of eggs or a dozen eggs is 12 eggs, or a ream of paper is actually 500 sheets, chemists use a unit called the mole to measure atoms. Now the mole has been abbreviated to MOL, I don't know why, and has the symbol N when we're doing our calculations. The mole is based on the number of atoms in 12 grams of carbon-12, which is 6.022 by 10 to the 23. This is known as Avogadro's number and can be found on the data sheet. Avogadro's number is huge. Look at the size of it. It's really big. And in fact, to give you some idea, if we were to have Avogadro's number of rice grains, it would cover Australia to 1 kilometre in depth. Now a mole is simply anything that has 6.022 by 10 to the 23 particles. So I can say a mole of zinc has 6.022 by 10 to the 23 zinc atoms. Or I can say a mole of argon has 6.022 by 10 to the 23 argon atoms. Or I can say calcium sulfate, 1 mole of that, has 6.022 by 10 to the 23 formula units to it. So let's look at a couple of examples. In the first example, we've been asked to find how many atoms are in 1 mole of calcium. So let's have a guess. If I have 1 mole of calcium, then I in fact have 6.022 by 10 to the 23 atoms of calcium. Now let's try the next one. This time we've been asked to find how many molecules are in 1 mole of nitrogen gas. Well, nitrogen itself is a molecule and it is N2. So if we're trying to find out how many molecules are in 1 mole, then guess what? There are 6.022 by 10 to the 23 molecules of nitrogen. Now our final problem says how many atoms this time are there in 1 mole of nitrogen molecules. So if there were 6.022 by 10 to the 23 molecules of nitrogen, using the formula, you can see that there are twice as many atoms. So the number of moles of atoms would be 2 times 6.022 by 10 to the 23, which would equal 1.2044 by 10 to the 24 atoms. Now you can see here that the terminology is really important. So you're going to have to read the questions extra carefully. Now, from the simple proportion, chemists have come up with a very simple formula to allow you to calculate the number of moles. And this formula is number of moles equals big N over 6.022 by 10 to the 23. Now the little n, if you remember correctly, represents moles. The big N represents the number of particles. Now a particle could be an atom, it could be a formula unit, or a molecule. Now this is always going to be a huge number because remember, if we've got a mole of something, it's ginormous. It's got a lot of things into it. So it's always going to be the big number. So that's why we use the big N, the big number. Now this number here, of course, is Avogadro's constant. Now I'd like to do a couple of sample questions with you. The first thing we're going to do is we're going to read the question very carefully. It asks us to calculate the number of moles, and remember mole is represented by the symbol N, and we've got this really huge number of atoms. So that is a huge number, so we give it the symbol big N. Now we've been asked to find the number of moles of zinc. So I'm going to tell my marker that I'm actually trying to work out the number of moles of zinc. And we write down the formula. It's very important your marker knows exactly what you're doing. You want them to be your friend so that they can give you as many marks as possible. Now from there we're going to put in the number of atoms. And you can work this out using your calculator, and it comes out to 2.5 moles. Now we need to know how many significant figures. We've got 1, 2, 3, 4, so we need to put in 4 significant figures. And the unit is mole. Now let's try a second example. It says how many carbon dioxide molecules are there in 1.5 moles of carbon dioxide. So the first thing we're going to do is write down our formula. Number of moles of carbon dioxide is equal to big N over 6.022 by 10 to the 23. Now we need to substitute in our numbers. So we've got number of moles, which is 1.5, equals big N over 6.022 by 10 to the 23. The next step is to rearrange the formula. Big N is equal to 1.5, 6.022 by 10 to the 23. And this comes out to 9.033 by 10 to the 23 molecules. Now, we had 1, 2, 3, 4 significant figures here, and I've given my answer to 4 significant figures as well. Now, what I'd like you to do is go to your OneNote under the chemistry calculations and the mole concept, and I'd like you to do the practice examples on the moles and number of particles page. I would like you to do this before you come to your next class. Thank you.